Well, I got a paper submitted. We got to do the first round of peer review.
Nice. On this or just recently?
No, on another topic,
Okay.
on the economics of lunar propellant.
Okay,
Lunar derived propellant.
nice. Do you want us to write something about it?
But let's let it get through peer review first.
Okay. It's a journal?
It's submitted to ACRA.
Oh, that's still that you. I think if you press enter, it should be good.
Yeah, this is, I don't know how to get, okay, maybe we can just do this. No, see, it's not.
Enter?
Okay, exit, I did a presentation. Like this.
Hmm? Well, let's see. John had seminars. Oh, this is what I was saying, that the bar for it all disappeared. I don't know where it went. Oh, maybe it's because we're in a dual screen mode. Maybe it's over in the next screen. That's it.
Oh, nice. We solved it.
But you see the screen.
Yeah, yes, let's.
Okay. All right, good afternoon, everyone. We are starting now. Apologies for the delay, some technical difficulty as always. As we're here for the FSI Seminar Series, and the topic for the semester is regional diversity in space research. And today we have Philip Metzger. Dr. Philip Metzger is a planetary scientist at FSI-UCF, and then performing the research related to solar system explorations. Before he was at NASA Kennedy Space Center for 17 years, where he led projects to develop extraterrestrial surface system technologies and led agencies work in the rocket blast effect for human class missions. He also participated in architecture studies for the lunar architecture and the Mars architecture. He also co-founded the KSC the Swamp Works and NASA's biannual workshop on granular materials. And he's a founding member of the ASC Technical Committee for Regulate Operations, Mobility, and Robotics. He receives shaped the Astronaut Silver Snoopy Award in 2010 and was selected as the Kennedy Space Center NASA Scientist Engineer for the year 2011. I think he also has some approved patents and pending patents for the related technologies. And for today, he's going to talk about the Great Depressions of Planetary Science in the range of 1910 to 1955 and astronomy loss of the Copernican planet concept. Phil, time is yours.
right.
Thank you.
Thank you. So can you hear me? Can they hear me online?
Yeah, I can pump the sound over there.
Okay, all right, so this is going to be a history of astronomy talk. And I just want to say at the start, I'm not really talking about the definition of a planet. What I'm going to talk about is the concept of a planet, which is more basic than the definition of a planet. So once you have a concept, then you can try to write a definition for it. But I want to show how the concept of a planet has evolved dramatically many times, not just once at the Copernican Revolution. But according to cognitive scientists, a concept is more nebulous than a definition. It involves ideas of what something's made of, what are members of that group, what groups it's a member of, relationships with other things. Like if somebody says, find a table, you can go in a room and there's very many weird different shaped objects, but you can sort of know which ones are tables, although there are some borderline, I don't know if that's really a table or not, but like that one over there, that cart with wheels on it, is that a table? But we generally have a concept of a planet, and we've gotten by quite well without a definition. But that concept itself has changed And that's what led to the confusion over trying to write a definition. Now, the reason this is important, we published 2 papers on this in Icarus, which is a planetary science journal. And the reason a planetary science journal published on the history of astronomy is because doing taxonomy is doing science. The concepts that we talk about in science have to align with the theories, because the concepts are the nouns, the theories are the verbs, and we need a language to be able to talk about the theories. And so these concepts co-evolve with the theories as part of the scientific process. Okay, so this is the talk outline. This is actually a flow chart of how the concept of a planet has evolved. This was the result of 5 years of study. It's documented in these 2 papers in Icarus, but I'm going to take this one block at a time. So we're going to start at that top block. I just put a red square around it, discussing ancient geocentrism briefly, and then we're going to go through the Copernican Revolution and what happened since then in the concept of a planet. So originally, from ancient times, planets were considered to be stars that moved in regular patterns in the sky. So there were 2 kinds of stars, fixed stars. They moved too in the ancient geocentrism, but they moved together around the Earth. And so because they were fixed relative to each other, they were called fixed stars, although they moved. The planets, on the other hand, moved at a different rate. And so they would move relative to the background stars. And so they were called wandering stars. And the word in Greek for wandering is planetal, which is why we call them planets, because they are wanderers relative to the fixed background of stars. In European and Mediterranean culture, they were understood to be 7 planets, because the sun and the moon were planets. The Greeks actually understood that Jupiter is larger than the moon because of geometry, it looks smaller. And so they didn't think the big size of the sun and the moon made them non-planets. But it's different in different cultures. The Chinese counted 5 planets. Vedic culture in India counted 9 planets. Scholars think the extra 2 planets are the serpent, which is a dark, invisible serpent that wraps around the Earth that swallows the sun and the moon periodically, causing eclipses. And then the comets would repeatedly return to our solar system, which was considered the 9th planet. But in the European culture, the planets were understood to be very different from each other, because one of them, the sun, makes its own light. Another one, the moon, is opaque but reflective. The other 5 planets, it was not known if they made their own light or not. But they were a diverse group in terms of intrinsic properties. The only thing that made them common was their dynamical characteristics. They were all thought to be made of unchanging ether. The primary point about cosmology in ancient times was the distinction between the heavens and the earth. The earth was chaotic, decaying, there's death. There was no science in the ancient world because everything seemed chaotic and you can't predict it. But the heavens were orderly. The stars moved in regular patterns. You can build temples in the Yucatan Peninsula. I've been to one of these temples where they would study the stars and track the stars. And this was a worldwide cultural phenomenon. And so they believed the heavens were orderly and unchanging. They always followed the same predetermined paths. And therefore, the earth was made of 4 essences, I think earth, wind, water, and fire, but the heavens were made out of the 5th essence, which was quintessence. And the quintessence was also called ether. So that was the primary point of the cosmology. But another point is that in cultures all around the world, European, Chinese, Vedic, Mayan, Mexican, Babylonian, everybody came to the conclusion that these things that move around the sky are intelligent beings. And you can kind of see how they would come to that conclusion. They seem interested in us because they keep going around us over and over again. They seem to be interested in what's going on down here. Otherwise, why would they keep going around us like that, right? And they're following an orderly path. They must be intelligent to be able to do that, in a pre-scientific world. And so everybody got the idea that they must be intelligent beings and they're doing something to us. So let's study them to see what they're doing to us. And that's where astrology came from. So in European culture, which is the background for the Copernican Revolution, it was influenced by Greek, Roman, Jewish, and Christian worldviews. And they believed every planet was specially created by God for a purpose. More about that later. And each was associated with an intelligence, a god or an angel later in Christian worldview, or maybe inhabited by a soul. The Greeks believed that the planets had souls, and they used that in philosophy to explain how they were able to move. But in 1277, Bishop Tempier of Paris condemned the idea that planets have souls. But nevertheless, even as late as 1600, Kepler believed the sun has a soul. I've read that in his writings. And he argued it must have a soul because otherwise, how does it produce heat and light? So in a pre-scientific worldview or an early scientific worldview, there was still belief that planets are souls. And as they're orbiting the Earth in this worldview in Europe, they are filtering down the influences from heaven, mediating them so that they have more orderly influences on the Earth. And for example, when you get sick, it's called influenza because that was the influence of the planets. So that's just one example, but it was a very thoroughly developed concept. Astrology was. It touched every aspect of life. Alchemy, the 7 metals went with the 7 planets. The diseases in the body were believed to be controlled by different planets, and so forth. And we think astrology is not a very respectable thing now as scientists. But Kepler and Galileo were astrologers. They made a living by doing astrological prognostications. Like that middle picture there is Galileo's own handwriting. This was an astrological chart, and he would do these and sell them to his patrons, the kings and the other leaders in Europe, and they would pay him for making predictions from astrology. And so did Kepler, because it was respectable at the time. It was considered part of mathematics. So moving on to the next box in the outline, something happened which dramatically changed that concept in the human's head about planets from all prehistory until the 1600s. Well, it really started in about 1543, where Copernicus wrote his treatise on how the sun is the center of the orbits of the planets. Galileo in the 1600s was very instrumental in moving that worldview forward. And this is what we've been told. At the Copernican Revolution, the concept of a planet changed so that the sun became a non-planet, the moon became a non-planet, and then the planets were the things that go around the sun. And that's what astronomy textbooks say happened in the Copernican Revolution, but it's completely untrue. We were shocked in doing this research as we started reading things by Galileo and Kepler. There was 100% universal agreement that moons are planets. And this wasn't just a random factoid. They were planets for 3 very important reasons. So they switched to having a intrinsic definite concept of planets so that the fixed stars become the luminous ones that make their own light, and all the non-luminous but reflective objects are the planets. And Galileo said that specifically. Okay, so I'm just going to give you 2 examples. We have like about 500 pages of supplementary material with all the quotes throughout all history that we've gathered together. We've outlined them, organized them with tables of contents. They're in 3 files. You can get them at my website, philipmetzger.com, because we wanted everybody to be able to check that we're telling the truth. We're not making this up, and we're not cherry picking the data. This is universally unquestionable. So these are just 2 examples from 500 pages of examples. Huygens in 1659, he's the astronomer who found Titan at Saturn. He said, for it appeared that the 2 neighboring appendages clinging to Saturn, those things, were by no means 2 planets, but rather something different. They were rings. While distinct from these, there was a single planet at a greater distance from Saturn and revolving around him in 16 days. So he called Titan a planet, although it's orbiting Saturn. And then here's an example from a Guatemalan textbook in 1868, hundreds of years past the Copernican Revolution, they were still doing this. And I translated this from Spanish. It says, what is the other way that planets are divided? They are divided into primary and secondary. What are the primary planets? Planetas primarios. Those already named, because they had already given the names of the primary planets in the book, so-called because they only revolve around the sun. What are the secondary planets? Planeta secundarios. Those that revolve around a primary, also called satellites. So for hundreds of years, moons were part of the concept of planet because the concept of a planet had nothing to do with what it orbits. That was not even in the concept, much less a definition. The concept was that they are geological objects distinct from stars. Okay, so the concept of planets was, remember this picture I showed at the beginning about the scientific method. The reason they developed this concept of planets is because it aligned with the arguments, the cutting edge theory about planets and about the cosmos. And Copernicanism used at least 3 primary theoretical arguments to prove that the Earth moves. And they all depended on the moon being a planet. And we found no theoretical arguments in the literature that would have benefited from making the moons into non-planets. Because there was no benefit to doing that, they didn't do it. So here's the 3 arguments that you can find in the literature. Argument number 1, the argument from celestial physics to earthly physics. So Galileo pointed a telescope at the moon and he argued the moon is not perfect, unchanging ether, but is a geological and evolving body. He called it another Earth. This was shocking because it violated the primary division in cosmology between the heavens and the earth. He argued that the moon, which is in the heavens, follows earthly physics. It changes, it decays. It's a geological body following earthly physics. Now, they knew the earth was small relative to the heavens. They knew that the heavens went all the way around the earth. So if you simply say earthly physics is everywhere, take away that domain boundary, by definition, the earth is now in the heavens. And if the earth is in the heavens like all the other bodies, then it can move like all the other bodies. And so this is an argument they were making, that the earth is in the heavens because the moon has geology. And here's Galileo in 1632. He says, many detailed parallels were drawn between the earth and the moon. More comparisons were made with the moon than with other planets, perhaps from our having more and better sensible evidence about the former by reason of its lesser distance. So the moon was the only planet close enough to see mountains. And so it was crucial for being able to make geological arguments about the planets. Now, if they had said the moon is not a planet, they would have no basis to say all the planets are geological. The only one they could see was the moon. And so it would have undermined the whole nature of his argument to say it wasn't a planet. So he didn't, he kept it as a planet. Secondly, the argument from luminous properties of planets. Galileo in 1611 said, I have most conclusive arguments ready, showing clearly that all the planets receive their light from the sun, being by constitution bodies dark and devoid of light, but that the fixed stars shine by their own proper light. So in that, he's saying the sun is a fixed star, the sun doesn't move. But then he also argued that he could see earth shine on the moon, like in the craters of the moon. He could tell when there was earth shine in those craters. And he argued from that, he said, if we could get away from the earth and look back at it, it would be a brilliant star, just as the other planets are. And therefore, the earth is a star, just like the planets are stars, they're wandering stars. And if the earth is a brilliant star, but yet we look at the ground and we see it's not making its own light. So it's opaque and reflective. And then he argued the moon is opaque and reflective. And then he saw the phases of Venus. Venus is opaque and reflective. So from those two planets, the moon and Venus, he argued the earth is the same type of object as those two. And by class similarity, he said all the objects of that class probably share the same other properties, including dynamical. So therefore the earth also moves, just like the other opaque reflective objects in the sky. So again, if he had said the moon is not a planet, it would have undermined that argument. And then the third is the argument from polycentricity of the planets. So geocentrism was an inherently monocentric system. The reason the planets go around the earth is because the earth was the lowest point in the cosmos. You come from high up all the way down to the earth, whichever way you're coming, the earth is the bottom. It was not considered an exalted place by being in the center. It was considered the lowest, most shameful part of the cosmos. That's where all the decay and death is, down here on the earth. But so it was inherently monocentric, and that's why the planets go around us. And people argued back a bit against Copernicanism, saying, if the Earth moves, we would leave the moon behind. But when Galileo found the four moons of Jupiter, he said, aha, see, they're not being left behind. But he called them planets. So here's a quote from him from 1610, 4 planets revolving around the star of Jupiter. I should disclose and publish to the world the occasion of discovering and observing 4 planets. He wrote it in all caps. That's not me. He did that. 4 planets, never seen from the very beginning of the world up to our own times. These are my observations upon the 4 Medicean planets. He named them Medicean after his patrons, the Medici family. And then in another place in 1610, he wrote, for now we have not one planet only revolving about another, the moon going around the Earth, while both traverse a vast orb about the sun, but our sense of sight presents to us 4 stars circling about Jupiter, like the moon about the Earth. So if he had said moons are not planets, then he would not have established that planets can orbit around things other than the Earth. Because people could have said, well, the satellites are just appendages to Jupiter. But they go with Jupiter because there it's appendages. But he specifically wanted to argue that planets can orbit around things that are not the Earth. And so again, it would have undermined his argument to say that the moons of Jupiter are not a part of the class of objects he was talking about. All the evidence is that moons were planets. Being a planet had nothing to do with what you orbited. But nevertheless, it was important to be able to talk about their orbits, so they created subcategories. They divided the planets, as that previous quote showed, into the primary planets and the secondary planets. This terminology was proposed by Kepler. And so whenever you say Titan is going around its primary, that word primary as a direct heritage, we've used it continuously since Kepler proposed it. And that's kind of cool, I think. So Kepler wrote, how are the planets divided among themselves? Into the primary and the secondary. Well, I'm not going to read all this again, but then he ends up saying Jupiter has 4 such planets around itself, secondary planets. This continued throughout history. This is from 765, the Encyclopedia, which was written in French. It was the Encyclopedia of the Enlightenment. D'Alembert, I don't know how to say it, Julie, I'm so sorry.
It's fine.
D'Alembert wrote in 1765 that this was an encyclopedia. So this is trying to represent to the non-scientific public a true and honest assessment of the state of knowledge. And he defines satellites as planets. And I'm not going to read the whole thing, but you can go to our supplementary material or the 2 papers to read these. William Herschel in the late 1700s, when he discovered Uranus, he wrote, I confess that this scene appeared to me with additional beauty as the little secondary planets, that's Titania and Oberon, seemed to give a dignity to the primary one, which was Uranus. So they were still using that terminology, calling them planets in the late 1700s. Okay, how about the mid-1800s? Crampton, writing about lunar geology. Scattered over the moon's plane, an infinite number of circular pits sink in the body or crust of the planet. And he said, to a vast distance over the surface of the planet, calling the moon a planet. And later in the book, he says, satellites are small planets attached to the larger ones, called their primaries. That was mid to late 1800s. German, we looked at German books. I had a hard time translating some of this because it's written in this really strange script, you can see over here on the right, and Google Translate doesn't like it. And so you have to go and hand correct every darn thing, and it takes hours and hours. But we read a lot of German texts, and it's the same thing in German, French, Spanish, Latin. Oh my goodness, translating that is hard, unless you can speak Latin, which I don't, or know Latin. Okay, 1870, late 1800s. This is a manual written for astronomers, a manual of the elements of astronomy. There are 2 kinds of planets, primary and secondary planets. Primary planets are those which revolve around the sun only. Secondary planets, generally called satellites, are those which revolve around their primaries and with them around the sun. They were always careful to point out, or usually careful to point out, that moons go around the sun too, but they do it in a compound motion. Okay, and they included asteroids as planets too, even as late as 1870, and even later than that, as I'll show you in a moment. A book about the moon, discussing it as a planet, a world, and a satellite. The chapters on talking about it as a planet discussed its geology and geophysics. There was one chapter that's entitled The Moon as a World. That talks about it as an immersive environment where you could go and stand on it and experience what it's like to be on its surface. The moon as a satellite, that talks about its relationship to the Earth, tidal forces and those interactions, light going back and forth. So discussing the moon as a planet means discussing it in terms of its geology and geophysics. Okay, 1910, this was still the taxonomy in the 20th century. The satellites or secondary planets, over 20 in number, are all too feeble gravitationally to retain at their surface a proper atmosphere. True planets, all of these are, whatever be their distinguishing names, whether primary or secondary, whichever distinguishing name, true planets, all of these are. 4, they are solidified bodies shining by reflected light. And you can see they were still using Galileo's definition of a planet. And we find that definition all throughout the centuries, repeated over and over again as the definition of a planet. All the solidified bodies in space that shine by reflected light. Now, later, that definition was found to be inadequate because we started discovering smaller and smaller and smaller objects until it became a joke. And it was a joke, and I'll show you. Okay, so also at the Copernican Revolution, they already understood that planets can change orbits. You know, in geocentrism, they don't. You know, the heavens are unchanging. But René Descartes, is that his name? René Descartes. He had a vortex theory of planetary orbits, and Bernard Leboyer de Fontenelle discussed how a planet can be spun free from its vortex and pass through another star system. I wish I had time. This is a fascinating book. That's de Fontenelle right there. But his book, Plurality of Worlds, talks about civilizations on these planetary bodies that get spun from one star to another. And he talks about how these people living on these planets, actually comets, he called them comets, but they were considered to be very large planets, larger than a planet at the time. And they would enter in our system and yell, star, star, or sun, sun. And he goes, just like sailors nowadays yell land, oh, when they see land. It was really fascinating to read all his concepts there. But Halley, from Halley's Comet, Isaac Newton, Trowbridge, Moulton, Kuiper, all through the centuries, astronomers talked how planets, secondary planets can become primaries, primary planets can become secondaries, planets can become rogue planets, leaving their star, rogue planets can become primaries. They all understood this. One other point I want to make about the Copernican concept of a planet, which we have forgotten, most of us have forgotten, but historians talk about it, is that they immediately concluded, almost everybody, not Galileo, he was a little bit more of a hard-boiled scientist, but most scientists at the time concluded that every planet must have life on it. And not just life, but civilizations and intelligent beings. Here's Kepler's argument. It became evident that these 4 new planets, the moons of Jupiter, were ordained not primarily for us who live on the Earth, but undoubtedly for the Jovian beings who dwell around Jupiter. From that line of reasoning, we deduce with the highest degree of probability that Jupiter is inhabited. Now, what the heck is that? The argument went like this. In geocentrism, God made the planets to serve the Earth, and that's why they orbit the Earth. But if they don't orbit the Earth and they're way out there, then they don't serve the Earth. So what possible reason would God have to make the planets? And they didn't understand planet formation, so they needed to come up with an explanation for why they exist, a teleological argument. And so they concluded, well, they must have their own purpose separate from the Earth, and that means there must be beings on those planets. And so almost all Copernican scientists believe that all the planets have life on them. Here's a book by Christian Huygens called Cosmotheros. I wish we had time to read this quote, but he discusses what life is like on all the planets in the solar system, deduced from knowledge that there must be life on them. So he argued that at Saturn, liquid water would freeze, and you can't have liquid water, but to have life, you need some kind of liquid. So there must be a different substance that is liquid out there at the distance to Saturn. Well, turns out Titan has methane lakes and methane rivers. So he was right, but not for the right reason, you know, but it is kind of interesting. These are pictures of pumpkin homes. People were talking about they could live in pumpkins to stay warm on the moon. kind of crazy, but Stephen J. Dick, a historian, was writing about John Wilkes in his book, Discovery of a World in the Moon. Worlds meant civilizations. Later on, we started saying planetary bodies are worlds, but that was because they thought every planetary body had a civilization. That's why the word world came to have that meaning. Originally, world simply meant civilization. It did not mean planets. But he says, discovery of a world in the moon. This book emphasized that the moon world could be deduced from Copernican tenets. Deduced. He viewed the arguments against a world in the moon as no less dangerous to heliocentricity than arguments taken directly from the Earth's motion. Okay, next concept of a planet. Something happened next which changed that view, and that was planet formation theory. So this is Laplace, French physicist and mathematician. Now, in the modern view, there are two pathways for planet formation. There's bottom-up accretion, there's top-down disk instability and gas collapse. And we believe they both were operative. We think that the smaller bodies started out by accretion, eventually got bigger, became oligarchs, and then gravity became significant. But the disk instability may have directly started to create the larger ones like Jupiter and Saturn. So we think that there were two paths going on at the same time, but they didn't know this. And Laplace proposed a version of this, the top-down path, gas collapse. They call it the nebula hypothesis. The idea is the sun started out as a cloud, and as it began to collapse, to maintain angular momentum, to conserve it, it had to shed off rings of material as it collapsed. Each ring then coalesced into a planet. Now, because of this led all the scientists at the time to believe that all the planets were round, because they're coming down as gas, and gas would pull into a round shape, and then liquid, and liquid pull into a round shape, and then they solidify. They may be oblate because the rotational rate spins them out at the center, and so the oblateness gets locked in. And they argued about this in the literature. But then they started having trouble with the asteroids because they saw light curves, and they were trying to explain, how does a spherical body have a varying brightness as it rotates? And so Zach in 1802 argued that Ceres and Pallas are not planets, they're fragments, because a planet exploded, and these are just non-round fragments. That was quickly abandoned, but later people continued to wrestle with this question. I'm not going to read these quotes, but Eros, asteroid Eros, had a particularly large swing in its light curve. And they started arguing that it must be a double planet, two spherical bodies orbiting each other to create this light curve, because they had no concept that a body could form and be non-round. This is important later. That's why I'm emphasizing this. Okay, now the taxonomy was still useful. Planet formation was assumed to be the same for both primaries and secondaries. Observing the asteroids and the moons gave insight to how the large primaries formed. As Kirkwood wrote, Kirkwood from the Kirkwood gaps in the asteroid belt, he said the history of formation of every planet, both primary and secondary, would be precisely similar. So it was useful to keep them in the same grouping, and they did. But they no longer had to say that every planet must be a world, because now they had planet formation theory. Nevertheless, they kept believing every planet is a world, because there was another argument called the principle of plenitude. They said, well, God wouldn't have made or allowed all those planets to come into existence without putting them to good use. And so they would all be filled up with life. This is similar to the idea in Carl Sagan's movie Contact, where Ellie Arroway says, Dad, do you think there's people on other planets? And her dad says, I don't know, Sparks, but I guess I'd say if it is just us, seems like an awful waste of space. Well, that was the actual formal argument they used in the 1800s, even after they understood planet formation, to say every planet has life. Now, I want to know, how many of you have heard of the Brewster-Gould debate? Is anybody here studying planetary science? I know you are. Okay, have you heard of the Brewster-Gould debate? We should know about this. This is the equivalent of the Scopes monkey trial for evolution. Okay, this is the big thing that happened that revolutionized astrobiology. So it was a debate between a Scottish scientist and an Anglican theologian. But ironically, the scientist was arguing for the principle of plenitude, and the Anglican theologian was arguing from physics that planets are mostly not life-supporting planets because they're not habitable. And this debate went on for a number of years in the journals. They argued back and forth. And then Whewell, the theologian, was instrumental in getting the astronomical community to accept the fact that most planets do not have life because of natural processes in physics. Therefore, we have to give up the idea that every planet has life on it. And that changed the concept of a planet. They're no longer all worlds, but they are still geological, complex, changing bodies. But then the next thing that happened is they started finding smaller and smaller bodies. They kept getting smaller to the point that it became a burden to keep finding them and computing their orbits. You can hear them complaining about it. They still called them planets, but they were getting antsy about calling them planets. And one German astronomer, Humboldt, jokingly started calling meteorites pocket planets. It's a planet you can put in your pocket because it's such a small planet. And so the reason it was a funny joke is because everybody got the point, yeah, that's kind of the direction we're going, isn't it? The planets are getting smaller and smaller, it's kind of losing meaning. But that happened. And so the concept of a planet was de facto stretched. So not only are they not worlds, but they're smaller and smaller. Well, meanwhile, this is what happened in culture. I'm gonna have to fly. But the public's, what time is it, Daka? I don't have the time on here.
You have 20 minutes.
Okay, the public rejected heliocentrism. So Copernicus wrote his book in 1543. Galileo wrote his materials in 1602, 1610. And then by the 1700s, the public still did not accept it. By 1800, they were finally starting to accept heliocentrism. It was the Enlightenment that caused the public to finally start to accept it. But when they did accept it, education was really poor. I scanned through a whole repository of 1800s textbooks. There was not a single word written about astronomy or planets in any book that I searched through, except in the eclectic readers, they would mention the planets as allusions in literature, like Mars, the god, the red god of war. That would be the only mention of a planet in their entire education. Well, where did they learn about about planets? Where did the public learn about planets? They learned it from astrology, and the public grudgingly accepted heliocentrism, but they didn't want to give up major cultural aspects of geocentrism, so they brought them into the new worldview, including astrology. Almanacs, so the astrologers like Kepler and Galileo, they had to stop being astrologers because it lost credibility in the 1600s. Scientists started to realize, all these predictions don't come true. And why would they? These are planets that are so far away. Why would they come true? And so starting in the 1600s, they couldn't get patrons to pay them to be astrologers anymore. So the astrologers switched over to selling mass-produced cheap books to the public with astrology to make a living. And I'm not guessing, this is what historians have written about it. They say that this was a process that occurred, and then the occult ideas like astrology got pushed out of the upper echelons of society down into the lower echelons, and astrology survived. But the almanac compilers wanted to make astrology appear scientific, so they accepted heliocentrism, but they had to make it appear reasonable. And if you've got hundreds of small planets like asteroids, you couldn't possibly take any astrological meaning out of that. Even if they invented meanings for all these planets, people would be like, how do you know that? The ancient Greeks and Hebrews, not Hebrews, but the Greeks and the Babylonians and the Egyptians, they only knew 7 planets. So where are you getting all this new information? So they needed a simpler concept of a planet to write these books, and they invented their own concept of planets. And I've got a collection of I'm starting to collect almanacs. It's kind of cool. You can actually buy them and find them in used bookstores from the 1800s and even 1700s. You might pay $30 for a little flimsy book, but they're kind of cool. But I looked through online repositories of almanacs, through hundreds of them, and we found out that there were 3 different competing concepts of what a planet is in these journals, in these almanacs. The first was phenomenological geocentrism. They kept saying the sun is a planet, even though the other planets go around it, even though it makes its own light. The sun is still a planet. The moon is still a planet. The earth is not a planet. Okay, this was in a lot of almanacs. The second group of almanacs, they combined geocentrism and heliocentrism together. It's a big tent approach. Okay, the sun is still a planet, the moon's still a planet, but the earth is a planet too. They're all planets. And so if you read these planet lists, the sun's included in the list of planets, the moon's included, the earth is included, Herschel or Georgian, those were two of the different names for Uranus back at the time. They started to add the first 4 asteroids, but they ignored all the other moons because you can't use the other moons in astrology. And they ignored most of the asteroids. And then finally, a lot of the almanacs were using a simplified heliocentrism. So the sun is not a planet, the earth is a planet. The other moons were not planets, and so they eventually removed the moon from their list for consistency. And most of the asteroids were removed. Well, this is the version that survived. Out of those 3 versions, for whatever random reason, this one became the winner. Maybe because it's closest to what the scientists were saying. And so the theologians played a role. The theologians were arguing that the planets show us the orderliness and the benevolence of the cosmos. And the asteroids didn't fit that pattern. They're messy, they're chaotic. What purpose could they have? And so they created this pseudoscientific theory that the asteroids are an exploded planet. They resuscitated something the scientists briefly considered around 1802 and then almost immediately rejected. But this was resuscitated in the 1800s. And so here's a quote from Dick in 1838. Having been accustomed to survey the planetary system as a scene of proportion, harmony, and order, we can scarcely admit that these bodies, the asteroids, move in the same paths and are arranged in the same order as when the system was originally constructed by its omnipotent contriver. And then he says the hypothesis of a planet exploding maybe explains the asteroids. And this, we can find this concept in many books. This is a poem I found, which is very fascinating, by English poet Sarah Hale in 1848. And she argued there was a planet between Mars and Jupiter. She called it the guardian planet. And she said the purpose of the guardian planet was to watch over the earth and mostly to watch the woman in the Garden of Eden. And at the moment she ate the fruit, that planet exploded. And that's where the asteroids came from. So, you know, I mean, they really didn't want to believe that asteroids were part of the original order of things because they're too messy. And you can find other quotes saying this. This guy said that the asteroids should respectfully be regarded as the result of some moral cause. Okay, when you look at all the literature, you can break it into professional literature, like Royal Astronomical Society publications, letters between scientists. And then the second tier is educational. This would be like high school textbooks written by non-astronomers, like geographers and other professional educators. Third tier is cultural. That would include the astrology and the sermons and theology books and poems and plays. I even read plays because they mentioned planets. You know, this is 5 years of research. And then the last is the oral traditions. And what we see is that the scientists, the top tier, switches from geocentrism to Copernicanism around 1600. The educational tier switches over around 1700 to Copernican concept of planets. The culture around 1800 was resisting it and not accepting it. And they invented their own concept, this simplified heliocentrism, folk taxonomy, in which moons are not planets and asteroids are not planets. And then we find that in the later, like around 1860, the first educational books start to use the folk taxonomy. They stop using the one that came from Galileo. And then in the 1920s, it comes into the professional literature, and we start to see it in actual astronomy texts, where people are no longer calling moons planets anymore, 1920s. Okay, so why did that happen? Why did the astronomers, what is this?
Yeah, you just lost your internet connection, you think?
I only have one bar. I don't want to do password resets right now.
I think that sometimes when you speak, we see your slide.
What's that?
I mean, on the big.
Would it be easier if a student logged in onto the UCF website?
Give me a moment, I think I can get this back. It says it still got it.
You see a guest?
I think you need to restart the share.
Reshare the screen, okay? I can figure out how to get to that. You said officially is,
You moved it out of the way.
oh, yeah. It's in the other screen. It's over here somewhere where I can't see it anymore. Well, yeah, but it's got two screens and it's over on the right screen that I can't see.
Oh, we did.
Did you send it to downtown?
Yeah, you wanna,
And Dr. can do advanced.
yeah, okay. Well, why don't I just keep talking for the sake of time while we're trying to do this? What happened was,
Like, if does anybody have questions, and you could do that.
Okay.
Yeah.
any questions so far then?
I have one, actually.
Sure.
So on the previous slide, you were talking about, well, you actually directly stated light curves. Did they know what light curve analysis was in the 1800s?
They were discussing it. They discussed, well, this was late 1800s, but mostly in like 1900 to 1930. They were discussing, trying to figure out why these light curves were happening. And they started talking about, well, there must be spots on these objects. So the asteroids must be spheres, but have spots on them. And so they were discussing that. And then it was really around late 1930s, 1940s, they started to realize these objects are not round.
So did they have a way of measuring like the changing brightness, or was it like, or was it just like, oh, we can see that clearly isn't as bright as it was, X?
Yeah, I don't know. I didn't read any technical details about how they did the measurements. But there were quite a few papers in the literature discussing it. I didn't pay attention to the instrumental details.
I just found that very interesting. Like even as early, even that early, I'm just always amazed what astronomers were able to do before we had all this technology.
Okay, so DACA, you should get it pretty soon.
So I saw that it took them 100 years to move science into education. Would you say that process of, transforming new scientific concepts into, an educational program has been streamlined nowadays?
Well, I
Have you
guess.
gotten better at this?
Well, absolutely, because there was just no science education in the 1800s. There was very little education at all for most people. But there was no science education. I found pamphlets from Britain in the late 1800s complaining about how bad education was. They even mentioned at one point that there's no education to tell you that planets have orbits. They even mentioned that. But somewhere from the late 1800s until now, we've improved education a lot, but I don't really know the details. Did you get the email yet, Doctor?
I think you have a like internet issue. I think we can go with a camera technique. If you speak from here, people can see the screen.
All right, let me slide over there then. So I'll unplug it from here. Is that okay? Unplug it from this?
People, we want to see it
No,
over
what
there.
he's saying is that the camera is going to pick you
I
up
can't-
and show you.
camera will
the-
pick you up.
It's just so I can
I think
change
they'll bring you guys
slides.
some notes.
Mhm.
Okay, I'll go back and forth. So anyways, what happened is this, around 1920, astronomers stopped calling the moons planets. And when they gave planet lists, they no longer said primary and secondary. Instead, they just said the planets are, and then they would list the ones that we've always called the primary planets. And the moons became a separate category of non-planet. And that happened starting in 1920 through about 1940. Now, when we looked for the reason for this, there was nothing in the literature that said that scientists had come up with a theory that benefited by making moons into non-planets. Culture did. Culture was doing good taxonomy. They wanted to have theories about orderliness in the cosmos. And in order to create a taxonomy that gave them the language to discuss it, they came up with their own taxonomy about planets. So that was actually functional taxonomy for those cultural purposes. But in science, there was never any theory that said we're going to benefit by making moons a separate category. It was never discussed. Just for some reason, they stopped including the planets on the lists. So we tried to investigate why, what happened here. And this is Bibliometrics publication counts per year for papers mentioning astronomy, planets, or satellites. And you can see from the discovery of Uranus, they all started growing at this high exponential rate. This is a log plot. So this is super rapid growth of astronomy, planets, and satellites. But in 1894, astronomy went flat, and it stayed flat until about 1955, well, about 1950. But meanwhile, starting around 1910, suddenly papers on satellites declined, and this is a 2/3 reduction. It'd be like 2/3 of the students at UCF that are studying planets, 2/3 of the faculty all got fired, and there's only 1/3 of us left.
They got sent to
Not just,
war.
not
What
just,
happened? They got sent to war.
yeah. Well, so was there a war that started in the 1890s between France and Germany?
1870.
1870s,
Yeah.
maybe it's the aftermath of that. But it's before the World Wars, and it's before the Great Depression. But it lasted a long time.
And
And-
World War I was in 1914.
Okay, that would be about right here.
Yeah.
So, this flatness in astronomy had already been going on since 1894. So, we couldn't find an explanation for that. We wrote that this is a good research project for some historian to look into. Why did the astronomical community stop growing for so long? But there was a 2/3 reduction in studies about planets. And that's huge. 2/3 of all of our colleagues all over the world getting fired and not publishing anymore for a whole generation. And it was during that time, they weren't really making much progress in planetary science. They were basically just calculating another decimal place on the ephemerides of the orbits of these bodies. There's very little scientific progress. And somewhere in that period, they just gave up Galileo's concept of a planet, and they started using the one that came from culture. And so we think it was just pedagogical neglect. A generation failed to teach the science to the next generation. And so the next generation fell into using what they learned in kindergarten about planets, and they lost the idea that moons and planets are the same type of object. And they started thinking the orderliness of the heavens is the most important thing. But then 1955, explosion of papers on satellites. And this is correlated to spacecraft missions being prepared. I mean, these papers talking about moons, you can see they're talking about when the spacecraft gets to the vicinity of Jupiter, what it's going to do. And this huge explosion, astronomy takes off. This is probably government funding. NASA was created right about that time. And at the same time, planetary scientists start calling moons planet again. So there was a brief period that we didn't, but that was enough. That was enough to make most of the community forget. Okay, so
If Europe was the driver of planetary sciences in the beginning, Europe was busy since 1870. Europe was busy to clear the French-German conflict here. Yeah.
yeah, I mean, there were wars in Europe for the whole time, weren't
Yeah.
there?
Yes.
Yeah, so I don't know. It's a mystery why it happened, but apparently there was a period of not being that excited about planets. Also, it was an exciting time in astronomy. They were developing galactic spectroscopy, cosmology, and so people who went into astronomy were going into those fields at the expense of planets because there was no growth in astronomy. So it was a zero-sum game. If you go into a different part of astronomy, that means one less person going into planetary science. Okay, so I'll skip over this for the sake of time, but the planet list changed. They no longer included moons. Okay, so what happened then next is the demotion of asteroids from being planets. And despite what you may have heard before, it happened in the 1950s. Okay, so this is what happened. It happened at the end of this Great Depression of Planetary Science. There was a burst in scientific activity, and this is when they first developed an understanding of accretion theory. So if you look at the bibliometrics on asteroids being called planets, It was fairly constant throughout 150 years, but starting in around 1950s, there were a series of key papers where Kuiper actually argued asteroids should not be considered planets because they were formed by a different process than planets. He didn't have it exactly right. He thought asteroids are formed by accretion, planets are formed by disk instability. But that was his argument. And he said because asteroids form by a different process and they end up lumpy, whereas planets formed by disk instability, gravitational collapse, and they end up round, they're two different types of objects. So these are true planets, these are not true planets, they're asteroids. And the community, right, starting then immediately stopped calling them, within 10 years, stopped calling them planets. And it stayed, this metric stayed flat for the next, what is that, about 40 years, until we started discovering Kuiper belt objects. And then the metric shows a spike as we're calling them small planets once again. Okay, so I'm just going to skip to the papers by Kuiper. The most important one is the one in 1953. He was asking, does disk instability really adequately explain the asteroid belt? He said no. Halfway through the paper, he changed his taxonomy and stopped calling asteroids planets. And he said that bodies formed by gas condensation are round and are planets. Those that form by accretion are too small, they're asteroids. He was not entirely correct, but he was trying to create language that corresponds with the theory. So taxonomy was functioning as it should. And then we've documented that since the end of the Great Depression of Planetary Science, there's been an increasing tendency to call moons planet again. And we have many, many pages of examples of this. But why were scientists doing this? Well, they always did it in the context of discussing complex geology, atmospheres, mantle and core physics, oceans, etc. That is the case where they would call it a planet if it was a moon. In other words, discussing complex geology naturally motivates us to create words that encompass the set of bodies that we want to talk about. And the same as Galileo. He looked at the moon, he saw mountains, complex geology, and so he started calling it and the Earth a planet. There's an Earth as a planet literature, which is like a Rorschach ink blot test. You might think that the IAU definition is the definition of a planet, but when people talk about Earth as a planet, these are the topics that they talk about. It's all complex geology, has nothing to do with their orbits. When there's a course taught at Caltech, one of the 4 core planetary science courses, called Earth as a Planet. Again, it's all about complex geology, has nothing to do with orbits. When you look at all the different features of complex geology with a Venn diagram, no planet has all of these features, but they are percolating across the whole thing. If you tried to pull any one of these rings, they would all come together because they're all connected. The only thing that we could think of that connects them all is gravitational rounding. And Mark Sykes, head of the Planetary Science Institute, has argued that that's not coincidental. It's because gravitational rounding is when active geology starts to turn on. You start to get mantle convection, transport of energy and materials, which drives crustal processes, and etc. You could use geological complexity as the definition of a planet because it seems to be spiked up between gravitational rounding and nuclear fusion. Once you've got nuclear fusion, that great flux of energy breaks all the valence shell bonds. You can't have molecules anymore. So you can't have minerals, you can't have geology, you can't have life. And so stars, although they are complex, they are less complex than planets. Planets are more complex than asteroids and dust specks. And so life appears to be correlated to planets as far as we know. And so if you averaged over all the planets in the cosmos, including the ones that have life, you would find it's hugely spiked up between gravitational rounding and fusion. But the big picture is this. Only 0.01% of the baryonic mass of the cosmos is contained in the planets. 0.01%, tiny. 0.002% of the total mass, including dark matter, is contained in planets. And only 0.0005% of the total energy is contained in planets. It's an utterly tiny fraction of the cosmos. And yet that utterly tiny fraction is responsible for the great flourishing of complexity and life in the cosmos. And so something as profound as that deserves a name. You know, what do you call this class of objects? Regardless what they orbit, they need a name. Well, this is exactly what Galileo saw. He looked at the moon, there's mountains, he's like, oh, wow, it's like the Earth. It has these complex things. And so traditionally, this category of objects has always had the name planets since Galileo, regardless what they orbit. And I would argue this is one of the most important discoveries of science in all of history. The concept of a planet as being the place where all these complex things happen in the cosmos. I think it's as important as almost anything else in all of science. So what happened in the astronomical community is, unfortunately, when asteroids were demoted, they kept moons as not planets. And so a lot of people ended up in this box, which is identical to the folk taxonomy. If moons aren't planets, if asteroids are no longer planets, we demoted asteroids for good reason. But if you demote them and demote the moons, you end up happening to be the same as the folk taxonomy that came from astrology. And so astronomers forgot the actual history and created a fake history. And this is called the presentism fallacy, interpreting past events as if they were motivated by modern beliefs that didn't exist back then. And so you find this is the history taught in the textbooks. They say moons became non-planets at the Copernican Revolution. They say asteroids became non-planets after we had found about 15 of them. There's absolutely no support for that anywhere in the entire literature. And there's gigantic argument that for the history that I've just shown you. So this is purely the presentism fallacy. But unfortunately, that's what informed a lot of the argument in 2006. I'll skip over the quotes. People will give you planet counts where they showed that it went back down in 1850, which is completely untrue. It went down in the 1950s for geological reasons, not for orbit sharing. And so this is really what led to this disagreement. Now, when the Division of Planetary Science created a definition they proposed to be the definition of a planet, it was rejected in 2006, and they on the spot voted on a different definition. That definition that was proposed was really not that great. It was not self-consistent. And I think that's because we didn't have time to digest all of this. We didn't have time to sort out the data and figure it out. And so they didn't have enough time, so they went there with a bad proposal. It got rejected, and so they voted in one that was consistent with the folk taxonomy. And they actually argued that we need to create a definition that the public will accept, has to have a small number of planets so the school children can memorize them. People were actually saying that. But what if that middle thing had never happened? What if there was no Great Depression of Planetary Science and we had kept teaching this concept all the way down to the present? Well, there would be disagreement between science and culture, but we would be using science to teach culture, and we would have ended up in this box as scientists trying to bring culture from here over to here. But it was this event, the Great Depression of Planetary Science, in the 1894 to 1955, that is what I believe led to the disagreement about the definition of a planet in 2006. So anyways, that's the diagnosis of what happened. And I hope you found some of that history interesting, at least.
This varies, so how do we fix it?
Just keep publishing papers.
I'm sure Alan Stern asked that question, no?
Yeah, so Alan was one of the co-authors here, and I mean, Alan got me interested in this. He asked my daughter and me to come up to the flyby of Pluto, and that was life-changing. But Alan asked me to write some blog posts for science outreach, and so I researched it, and that got me interested in that. So it was Alan that was responsible for me having an interest in this topic. But yeah, we've talked a lot about what we can do to get scientists to start doing more useful taxonomy. I mean, Neil deGrasse Tyson has said planet is not even a useful concept. I mean, because Mercury and Jupiter, they're so different. Why are they in the same category? And Mike Brown has written on his blog, it's not even a scientific question what a planet is. It's a cultural question. But you know what? What other branch of science says that? What if, and we've all probably said at some point, Pluto doesn't even care if it's a planet. I've probably said that. I know many people say that. Pluto doesn't care if it's a planet. What other branch of science says that? If you went to a biologist and said, are dolphins mammals or fish? And then they say, dolphins don't even care if they're mammals or fish. That doesn't happen in any other branch of science.
I say that. I've said that several times in the sense that, I mean, I love what you have done, because you have done real work, 5 years, researching literature, going after which is the definition of a planet and why it was what it was, when it was what it was. I mean, because there are reasons for everything, but it's focusing the like I have heard that done is like it's like the science that is done in Pluto is less if Pluto is not a planet. Even which kind of scientist says Pluto was demoted to not be a planet? What does that mean? Does that mean that the small bodies in the solar system are less important than the planets?
Yeah, so the press started calling it a demotion. And so a lot of people did emotionally react to that, the idea of a demotion. I've heard people from Europe saying that this is an American bias because Pluto was the American planet. And yes, people have played into that. And so there are a lot of entangled issues here. But
A lot of issues also, yeah.
yeah, there are a lot of entangled issues. But what I think and what I've heard Alan Stern say is we don't go make another definition of a planet. We don't go vote again. All we do is we publish papers and we argue this is the most useful taxonomy. And we can disagree. You know, people can, I mean, biologists have been arguing over the definition of species since before Darwin, and they still have not settled that question. And there are hundreds of papers in the journals arguing over what the definition of species should be. And I've read review articles where they review 46 different concepts of what a species is. And but they think they're close to getting consensus now. So it's only taken nearly 200 years. But you know, sometimes science is slow like that, and we just got to be okay with that. You know, that's the way it works. It's a community process. We can all disagree. We're supposed to disagree. We write papers, we argue in conferences, and in the long haul, something emerges. And so if we want to have faith in the process, just continue on. You know, that's the answer. Just continue on.
And actually, yeah, what?
Yeah, I mean, Noemi, like at FSI in particular, we will agree that it's not less interesting because it's a small body.
Well, the word demoted means exactly put in a lower ranked category. So I don't mind. I mind as much as demoted as much as saying it is not a planet or not. I'm just bringing that when he was saying which kind of scientist says this, well, okay, there is another kind of scientist that says the other. I mean, what we say, it's always affected by our personality, and the important thing is the science that we do. For me, to me, I don't really care what is called a planet or not, but I think it's important in terms of cultural, as you have said, and also in terms of being sure that the concepts that we have adjust to the reality that we know when we know it, you know. So, but I don't know, just wanted to bring that up.
All right, just if you ask me, the smaller, the more interesting. So
I know. I know.
All right, any other questions from online?
I'll just briefly add to what Noemi said, that everybody that I know who claims Pluto is a planet, it should be a planet, because the argument is not because it's the American planet. You know, the argument is we think that's a more useful concept of a planet that we can actually use to discuss theories. But everybody I know who says that agrees it's a dwarf planet. It's not a major planet like Jupiter or Earth or even Mercury. It's a dwarf planet. There's no disagreement over that. The only disagreement is over are dwarf planets a subcategory of planet? You know, is planet a useful term if you define it one way or the other way? That's the only.
So the EU specifically says that a dwarf planet is not a kind of planet. It's a different category. I don't know. They are like throwing balls into the air to be sure that they are don't bother anyone. You know, they don't piss anyone. And respect to what you were saying, the EIU, I mean, I was not in that room because I was a graduate student, but I was part of all the process in the sense that I was studying Iris Makemake already at that time, when as soon as they were discovered. And I know closely the people that wrote the other proposal. And it was not like they brought a wrong proposal, but we were not able to defend ours. And then, no, I mean, they came with a proposal. People said, we don't agree with all that is there. You have until tomorrow that we are going to do the vote, and people in the room will vote. And the DPS with their proposal had the same time to prepare and defend that than the others. And they did it.
I know.
And people in the room voted. It's just, I mean, I suppose it was a democratic way of the scientists voting what they wanted.
So
I always thought it was really stupid because when do you do science by voting?
Well, it's how things are done at the DPS, and it's how things are done in these kind of committees.
Yeah, so we've been arguing that it was a mistake to vote over taxonomy. You know, I didn't show this because I took it out for time, but this is the International Code of Zoological Nomenclature. And they say in here, the code refrains from infringing upon taxonomical judgment, which I can't read the small
Must
print.
not be made subject to regulation or restraint.
Which should not be made subject to regulation or restraint. In other words, you should never vote on taxonomy. This is in the biological code. And that's because they're arguing that scientists need to be able to argue taxonomy because that's part of doing science. So we think it was a mistake to vote inherently. The reason they thought they needed to vote was because they had a naming process for small bodies. They didn't have a naming process for planets per se. And because no planet had been named since 1930s with Pluto. And this is little known, but back in the 1930s when Pluto was named, asteroids were all considered planets. And so they didn't have separate processes for small bodies. I mean, they didn't know about many asteroids. Well, they knew about a lot of asteroids. And they named asteroids after major gods like Juno. And they named, now we're continuing to name Kuiper Belt objects after major gods, like Haumea is kind of a European-centric bigotry to say those are not major gods because they're Hawaiian and Polynesian. Only the European gods get to be the major planets. You know, that's who would ever say that? You know, I hope nobody would. But all these issues were entwined, and they thought, by golly, we've got to figure out if it's a planet or not before we can name it, because we don't know how to sort out the naming process. And that got entangled in this. And they literally broke the bylaws of the IAU because the bylaws say they're not allowed to bring anything to a vote unless it has been advertised on the website for 4 months before the General Assembly. And they made the decision to keep it a secret because they knew there was no consensus and they were afraid people were going to snipe at it and undermine the process. And they felt we have got to get a determination because we have got to name Eris. And so they broke their rules. They kept it a secret. Nobody had a chance to prepare. And so on the second day of the GA, they announced it and people were mad, rightfully so. And so they created another definition with just as much time as anybody else had because nobody had time. So that shouldn't have happened that way. And we're just arguing that they shouldn't have voted at all. Just change the naming process. You know,
Yeah,
just
I mean,
small bodies.
I think that was the result of, I don't know if there were more, but at least 2 of the largest egos in planetary science being involved and related to the same planetary body. And you named 2 of them when you gave different names.
So what would be interesting to look at is funding patterns. So, you know, for these different categories that they define, because I feel like in the more recent years, we've looked at increased funding into small bodies, really. So just Noemi a little bit, you know, to basically support the idea that it's not a demotion if you're a minor body, because, you know, if minor bodies are considered interesting and funded in order to understand planetary system as a you know, more general, you know, like, so I don't know if you looked into that at all.
No, we did not, but I did think about, is the voted definition hurting science or not? And I don't think it is. You know, I think we're able to keep on doing science, whatever the definition is, but the reality is a lot of people are ignoring the IAU definition and continuing to call Pluto a planet, continuing to call moons planet. Just like before, we're continuing, it's called polysemy, where you have different but overlapping concepts and you can communicate to each other because they overlap enough. And on the fringes where you have little disagreements, you can always tell by context, like, he called Pluto a planet. I'm not super confused by that, nobody's confused by it. And so it's not really a problem. But I think it's an abstract argument to try to say that science has been hurt by doing bad taxonomy. I don't think it has been hurt in any measurable way. But I would rather make the argument that it's just not good practice to do the processes of science poorly. We should be defending the boundaries of science and defending taxonomical judgment and taxonomy as part of the scientific progress out of principle, rather than trying to claim there's anything harmful.
You did seem to say that, the taxonomy they used to have was useful for the progress of science in the beginning. So you don't think it's that important now?
No, we do, because a lot of people are continuing to call moons planets, and they will do things like, they will write the terrestrial planets, and then they will name them Mars, Earth, the moon, and Mercury, and Venus. Left off Venus. Poor Venus never got enough funding, so. But anyways.
Because there's some sort of a pro demotion there too, right?
Yeah, and they'll talk about planets that have atmospheres, and they'll talk about Mars, Titan, and Pluto, and they'll compare these three objects and they call them planets. So we documented this in the supplemental material. There's a huge amount of people using the word planet in a way that they find useful, which is different than the definition from the IAU.
Right, we're over time though.
Yeah.
Right?
So we're over time, so I think we can complete the seminar for the purpose of recording, and then we can keep continuing the discussion.
Yeah, we did it for.
All right, yeah, let's thank the speaker again.